Hello everyone, my name is Suvi Joshua, contributor of GSOC26 with openmrs. Project I'm working on is support for horizontal scaling for openmrs instances. Why this project? Right now, openmrs as a system has a single point of failure because it is set up on one single server, and in case anything happens to this server for maintenance reasons or crashes or anything related to maybe physical catastrophes or anything, this single point of failure is very detrimental, and clinical workflows are actually stopped. And then another thing, as openmrs has grown over the years, we have seen users, increased number of users or increased number of usage, and as the more users increase, this has degraded performance at peak times, and one of the things that this project is trying to address is actually make workflows actually work at even peak load, at peak time or anything. So one of the things that I am doing is to enable multiple openmrs instances running simultaneously. When we have, let's say for example, 3 copies or more than 1 copy of openmrs distributed over a load balancer, in case one instance is down, maybe for maintenance, or if you need to do an upgrade, you can upgrade one and then have the others still working, or things like that. So this prevents the issue of one single point of failure. This presents as well 6 things that break openmrs core by its design, and this is startup races where multiple pods fight over liquid-based migrations, lost sessions, stale caches, zombie nodes, search inconsistencies, and also files being lost to one pod, files uploaded to one pod are not visible to others without shared storage. So one of the things to solve these 6 issues is to actually choose the right infrastructure, and the right infrastructure was to go with Kubernetes and of course Elasticsearch and unnecessary storage and MariaDB. But obviously the biggest capstone was going with Kubernetes as the infrastructure to solve this. One of the things that I did for the first phase was to migrate away from the Bitnami archived charts, and this was one of the most of the work that I did in the first phase, migrated away from the MariaDB, Bitnami chart, Elastic, and the Bitnami mini IO. We actually made a decision to move to Seaweed FS for S3 storage, being it's a lighter approach, and mini IO is actually archived. And also created a custom image, a custom Docker image that comes with phonetic analysis plugin for patient search. This is customized for the openmrs application. Also migrated from the Nginx Ingress to the more modern way of routing, which is the Gateway API, Kubernetes Gateway API, and we're using Trafiki for this. What this brings about is that you can now be able to access openmrs front end just using this prefix without having port forwarding or things like that. The Ingress, I left it preserved for backward compatibility, since other probably implementers are using Ingress, so this is still available but is disabled by default. When we moved to Trafiki and the routing, I realized and got an issue of sticky sessions, since openmrs uses a CRF guard. So one of the things I had to do was to enable sticky sessions for our routing, such that with round robin load balancing, the login post lands on a different port. Cookie-based session stickiness via Trafiki service, this is what actually I did to solve this problem, and it's actually automatic. Doesn't need any configuration. As long as you set your replicas to greater than 1, you actually get the sticky sessions enabled, but if it's one, you don't need it. So I also exposed Grafana and SeaweedFS admin dashboards, Grafana for monitoring logs, and then SeaweedFS for monitoring your storage, and these are also accessible via Grafana. The prefix for Grafana and then SeaweedFS. Of course, this comes after localhost 8080, then /Grafana. You can access your Grafana dashboard. Of course, as well, a route redirect to SPA. As long as you have set everything up, you just the localhost and whatever server that you use here automatically redirects you to the front end. The other thing that I did was to improve the development experience, to consolidate the steps that were more than 10 to set up your cluster, installing CRDs, having multiple prerequisites. I consolidated that into an openmrs operator chart that actually helps to install everything by just running make deploy. Once you run make deploy, you have everything set up. But in this I landed onto a pod hanging, the back-end pod hanging, because there was a competition. Tomcat was starting before actually MariaDB image or setup is done. So one of the things that I did was to actually edit the startup.sh file in openmrs core, where I set up a credential check, a credential verified for MariaDB, and of course increase the number of retries, such that Tomcat, when Tomcat starts, MariaDB is actually up and running. Okay, so what midterm evaluation found me doing, it has not yet gone in, but work has been done, at least for the start. Having many tenants share one cluster. The cluster, I mean the services like Elasticsearch, MariaDB, SeaweedFS, and the other services that run the entire cluster. You have multiple tenants sharing the same cluster or same pods to carry out their functionality. So this part of the work has been done, especially doing the skeleton tenant chart, and as we go on, I will be improving on this such that we are able to actually run many tenants but using the same cluster. Why the same cluster? Because it saves resources. In case you are running this on an AWS server or something, it will save you resources if you are sharing the same cluster. This is a statistics of what has gone in and what is next and what you should expect for the future. So this is the repository and its commit history to see the PRs that have gone in, and of course for now all the documentation is in the README of the repository. If you want to really know how to set up the cluster, you just need to go through the README. In the second phase, I hope to come up with a wiki. And because of time, I have not had time to give you a demo of how to run, but what you would need to do is just sit into your Helm and then make deploy to set up your everything, and then it starts up everything. Right, thank you very much. Thank you very much. See you on the other side.